In this contribution, entitled Combining Additive Manufacturing and Bioeconomy of Wood Towards Electronics with Net Zero Emission, we would like to present you some of the effort done by Holzfort Austria, EMPA, Profactor, RISE, and TNO towards net zero electronics. These activities are performed under the umbrella of the HyPElignim project. The HyPElignim project is an Horizon Europe project that has the ambition to demonstrate an holistic approach for the development of electronics with a net zero emission. One way of doing this, or one way we want to achieve this, is by combining hybrid printed electronics with low impact in biogenic material, for example, wood and lignocellulosic materials. The consortium of the HyPElignim project is composed by 11 partners from Austria, Switzerland, Spain, Slovenia, the Netherlands, and Sweden, with a good mix between research institutes and industry. More specifically, we would like to present you our early stage demonstrators of the manufacturing of hybrid print electronics components on two different lignocellulosic substrates, plywood board and EcoPCB board. Plywood is a commercially available wood engineered materials consisting of the lamination of several layers of wood called veneers. This is very interesting for us because it resembles quite significantly the multi-layer PCB currently existing. The other material that we want to manufacture electronics on is the called EcoPCB board. That is an engineered material developed by partner EMPA. The production of this starts with the separation of lignin-rich cellulose pulp using a Fabbrelli process, and this process is performed at partner TNO in the Netherlands. The obtained lignin-rich cellulosic pulp is then fibrillated at partner EMPA, and following a dewetting and hornification process, this results in a very rigid board. The board is then transferred to partner Profactor, where, by combining inkjet printing technology and pick-and-place technology, the circuit is manufactured and components, in this case a microcontroller and LED, are assembled on it. The result is a fully functional demonstrator that is able to harvest energy from a mobile phone to switch off an LED light, how you can see in the video. The second demonstrator that we want to show is the manufacturing of a wood Arduino-like board. In this case, plywood have been used. And what you can see here, plywood have been printed on both sides using commercial inks. Via have been manufactured using CNC drilling, and these have been then made conductive by using metallic rivet. Finally, in the different location of the metallic rivet, as you can see on the right side of the slides, you can assemble by soldering different PHT components, and this led to a nicely working demonstrator. But of course, we want to move also a bit forward with that one, and recently partner RISE, Infineon, and Hofforsk have been working on the development of the first demonstrator containing SMD components on plywood. This is a working in progress demonstrator and consists of a circuit printed on plywood on which a temperature and moisture sensor and a microcontroller from partner Infineon have been integrated using conductive adhesive. Is this straightforward? Well, it's not that straightforward, of course, because there are several things that need to be taken into consideration and several problems that need to be overcome. For example, inks tend to spread significantly on wood, and this is a very common problem with both the EcoPCB engineered by partner EMPA, but also with commercial plywood. A way of overcoming this one is by priming the wood. And how you can see, these have significant benefits on the definition of the printed line. Another issues that need to be overcome, and that we are all still working on, is actually the fact that wood, natural wood, has defects. And defects, as you can see in the image on your left, can actually create disruption into the conductive lines and then make the demonstrator or the built electronics non-functional. But this is something that we are still working, and hopefully we will be able to update you with our progress and with new and more complex demonstrators. And with these slides, we want to thank you for your interest, and please come to visit us at our website by using the QR code of the slides, or contact me at the email below if you are interested for further interaction and more insights.